Hello, dear all. We are going to make an lecture video about unit third, that is mining data streams. You know, uh, which is for subject data analytics, and which belongs to our IT branch. Code of data analytics is AI 601, as we know that. You know, right? Today we will understand from where our unit third has been there. First of all, let's have an understanding. In the unit third, we have mining data streams, and in our notes also, in our book also, we have mining data streams. Okay, so what really the mining data streams is all about? First of all, before understanding the mining data stream, we need to understand that we need to understand how this how come we are here for the unit third. As we know that in our unit three, we have the unit three belongs to this book, mining of the massive data set, that is of that is of Joe Leskovic and Anand Raja Raman and Jeff D. Ullman from the Stanford University. Okay, so here in this book, first of all, there is an introduction about the subjects, what we have, what we need to understand our data analytics. First of all, there is a small introduction of the data mining, you know, then statistical limits of data mining. Then we understand what really the map reduce and view software stack is. Second unit. Then the third, we have finding similar items. How the similar items are fine. Then only we are getting this unit. Mining data streams. How the data streams are going to map. So before understanding of this unit 4, which is introduced in our unit 3, we need to understand what really this unit tells us about. What really the data mining is, what is statistical modeling, what is that. So let's have a quick revision about it. So what is data mining according to this book? Okay, data mining is here. Data mining is the discovery of models for data. What is really the data mining is? Data mining is the discovery of models for data. A model, however, can be one of several things we mentioned below. The most important directions in modeling. Okay, so what really the model is? We have understand the model concept in the unit second, how the inputs and what the process is of the model from which we are able to get our definite thing by mathematical proposition. What exactly to get to the given population of the data. Okay, for that we have a statistical modeling. We have a statistical model that what is statisticians where what is really the statistical modeling is all about. So we understand in our unit second. We So what really that statistical model? Really the statistical modeling is. So statistical modeling, for an example, here we have an example of how really that we understand the statistical model for construction of the data mining. That is, the suppose we have a data. Our data is a set of numbers. Okay, this data is much similar than the data that would be data mined, but it will be served as an example. A statistician might decide that data comes from the Gaussian distributions and use a formula to compute that most likely parameter of the Gaussians. The mean and the standard deviation of the Gaussian distribution completely characterize the distribution and model the data. What is really the Gaussian is all about? What really the Gaussian is all about? See, Gaussian is something you have heard it about in physics. What really the Gaussian is all about? You heard it about the as a Gaussian thing, but here it is a Gaussian distribution. It is a very much different thing by your physics. And whenever you have a query, my way, it is there. What really the Gaussian is? Okay. What is this? A sample data will form a distribution. And by far well known for distribution is the Gaussian distribution, often called the normal distribution. The distribution provides a parameterized mathematical function. Understand very well. In the Gaussian distribution, you get a parameterized mathematical function that can be calculate the probability or the individual observations from the sample space. Okay. A Gaussian distribution belongs to the family of this stable distribution where the attractors of the sum of independent and radical distributions will form. And this is the formula. This is 1 by sigma under root 2 pi e to the power minus half n x minus 2 by sigma whole square, where sigma is the standard deviation and mu is mean. Okay. This is just for a kind introduction about the thing. So you should not be aware about the fact uh, what really the Gaussian distribution is. Check. Okay. Now let's do. So now we understand how the models are formed, how with the statistical collaborations. Now let's understand what really the machine learning is all about. There are some who regards data mining as a synonymous with machine learning. It's not like that. Uh, in the machine learning, we uses the algorithm of the data mining, but there is a very much difference between a machine learning and data mining. Machine learning practitioners use the data as a training set. You know, machine learning practitioners takes the data and it is used as a training set. And the machine learning, we have what are the machine learning exactly? Which machine learning have exactly used are the best? We have a regression modeling, multivariate modeling. We have Bayesian network. What about we have learned in our second unit, support vector machines, decision trees, hidden Markov, hidden Markov principles, okay, hidden Markov models, and many more. Which these are the mathematical models which we can use in our Bayesian, which we use in our machine learning. Okay. Okay. Now we got the difference. So now the thing is, we understand that the data is a very important thing in machine learning. And So then now let's understand this thing a little bit deeper. So there are situations where data. There are situations we need some, we are not getting the clear cut information from the data. Okay, so like many of the things that we have a random population sheet. Then so next is how we computationally approach for the model. First of all, there is a very much set pattern for that. We summarize the data and then we extract the prominent features from the data and ignoring the rest. That's the way we get the things done. We summarize the data in significant and approximately, and then we go for the extracting the most prominent features of data and ignoring the rest. So, in summary, if we need to understand what really the thing is. Let's have an example. Uh, how it's an example where a real life problem is solved by some mathematical calculations, like plotting the cholera cases on a map of London. Okay, from this way we understand that in London we have so much of the cholera cases, and we are able to understand the density and to define the plan accordingly. And this is we this is where the mathematics help us to get the things done. And how we understand that the two step for getting that from our data, we go for the two step. We summarize the data succinctly and approximately, and then we extract the most prominent feature and know the rest. We understand this from the data. We do these two things. So what really the thing is, then we uh, uh, in the second thing, extraction of the information, we do for the feature. We do the step which is known as the feature extraction. Okay. What really the feature extraction is? The feature extraction is a typical, we use a typical feature based model. We use a typical feature based models. Where we have an example how this is done on the larger scale data by where the first thing is we have a frequent item sets, like we're getting data from a different individuals, like in a platform like Google search, Facebook, and we get a frequent item sets. Okay, this model makes sense for the data that consists of the baskets of the small set of items, as in the market basket problem that we will discuss in chapter 6, and which is exactly the our unit 4 is, where there this frequent item set has been discussed. So, and the base thing about the thing is we have a model which makes sense, which consists of the basket and it's one sort of set of items for the market basket problems that we'll discuss. Next is frequent item sets. So, what are the frequent item sets? Frequent item sets are the characterization of the data that we see. And, it's it's basically it can be understand by some market basket problems, which is major problem of a major problem in the form some companies like Walmart, Spencer's, Reliance, Branks, and all those this model of getting all things at a one go. So where the customer's psychology is read according to the market basket problem, when it is implemented, it is implemented. So the thing is, how we are getting the things done is an important thing. So let's move. Okay, just, these are the known as the supermarkets, hypermarkets, where people come and take the items. In the further book, we have an example of how we characterize the things like when people has come and get this item, like milk, bread, and egg. And other one is coming for the egg. Other one is coming for, other one is coming for only milk. So how we able to analyze the data and extract some information from it, so make a plan and model to get things done and get futuristic idea what product we need to introduce in our supermarket. Right. Second case is of the similar items of how how we get the similar items. Often our data looks like a collection of sets, and the objective is to find pair of sets that have a relatively large fraction of their items in common. So, like Amazon, we have a set of items that are bought. As your Amazon recommends something, so Amazon can look for the single customer recommend something many of these customers have bought, and this behavior is called as this behavior in process is called as the collaborative filter. If the customer is single-minded, then they only bought one kind of the thing, then trusting customer might work. Okay, since customers tends to have interest in many different things, it is useful to find for each customer a small number for other customers who are similar in their tastes, and which we represent the things by the condition. So we have a two different idea to process the data. The other one is the frequent item sets. And what is the our focus point in our unit 3 and 4, and then how what is the user similar set is on. Well, we need to understand we mine the data through the statistical concepts, and there is always some limitations within that. Okay, now that things are there, we need not to dive about this, but it's for our only awareness. That there is something we have our limitation. Next is we need not to go dive on the data, but we should have a we should have an assessment. This is what the first unit all about, which is not our point of our course, but it's still I'm just going through the book for introduction. Now, after the frequent item set, what best thing we got that is a hash function. What really the hash function is? Hash function helps us to make a hash tables, which makes ability for a inject component in number of data mining algorithms. Okay, so hash table takes approximately when we know that whenever we have a hash function, we take a hash key for the argument and produce the bucket numbers as the results. And this hash function will help in calculating calculating our frequent item sets in the production, the feature extraction. The frequent item set part will be taken care by the hash function. Okay. Why I'm using FaceBooks once it important, because usually people don't read book. I need to take the book as a parameter to make you think in a way, and from which you got some conceptual outline to write the answers or to make the right options in the coming MCQ examination. Okay. Okay. this is then we have indexes. So index is a data structure that makes it efficient to retrieve objects from the value of one or more objects of those objects. Index gives us a value, how much data is encoded within that. Okay, within that parameter what we are searching for. Next is how the thing, array of buckets headers, how the things works in the bucket. We have a bucket headers and then we connect the data pointers as per the requirements. How the secondary, what is secondary storage? We know what is really the secondary storage is, and how they are calculated. The algorithm is discussed here. So algorithm is discussed here. I just give you an outline. What really the book which we are going to use. What really the book here has. So I have an outline of book, which is very important. Okay. In the chapter 2, we not about the data mining. We have introduction of the MapReduce methodology for exploiting parallelism in cloud computing, racks of interconnected. The reason to believe that the cloud computing and MapReduce in particular become the normal way to compute when analysis of very large data is involved, because it can be done on the single system. If you have a computer and if we think that we are able to go from a single processor, we can process the petabyte data, next to impossible. We need this technology. We need this parallelism, and we need this interconnected processes. We need a cloud computing also. So MapReduce indirectly say that we have a big data technology, and big data analytics is the part of it. So chapter 3, unit 3, unit 4, and unit 5 is actually a big data analytics in our subject. In our data analytics subject, unit 3, unit 4, and unit 1 is a big data analytics. In unit 3, we have able to go for some finding similar items. This is our starting point that items can be represented by the single item elements, and similar sets are those that have a large fraction of their elements in common. The key techniques of minimum hashing and locality sensitive hashing are explained. So min hashing and the locality sensitive hashing, it's not a this is the hashing techniques as we have understand in the first unit, that we will focus on in the coming units. We will focus in coming processing. In the coming minutes, we focus on the hashing and clustering as a technology for processing the large amount of the data. With an example, we understand how the clustering helps us to manage the cholera cases in London. Okay. So here we will get the technique of the minimum hashing and locality sensitive hashing. Hashing, we know in the hashing we have a hashing function and a hashing key, and which help us to make the searching very easy. Next is in the unit 4, which is our topic actually, mining data stream, in which we get a data in form of the stream. The difference between the stream and database, that the data in the stream is lost if you do not do something about it immediately. Okay, that's why sometimes we need to process the data before entering into our system. What example of streams are the stream of search queries at a search engine or clicks of a popular websites. In this chapter, we see several of the surprising applications of the hashing. So this is basically this chapter 4 is unit 3. Okay. This chapter 6 and the chapter 7 is our unit 4. And in unit 5, we have a page rank algorithm. Basically, this page rank algorithm is responsible for the search engine optimization. This is not part of our subject, but one should have an understanding in which way we are proceeding for the next topic. In the chapter 6, we got an introduction of the market-based model of data and its canonical problem of association, rules, and finding frequent item sets. So in the initial of the chapter, we understand how the data population is learned in the two-way by collecting and extracting information with a statistical model, and the writer also give us hint that every model has its presentation. And in unit second, we understand what is machine learning, and writer also said that There is a difference between machine learning and the data mining. So these all things, giving us a input for our chapter unit 4. Let's start from a chapter 6 of this book. So introduce the market basket model of a data. Its canonical problem of the solution and finding frequent item sets. In the market basket model, data consists of large collection of baskets, each of which can contain a small set of items with a sequence of algorithm capability of finding all pairs of items. Okay, in the chapter 7 we introduce the clustering concepts. Actually, until the chapter 7 we are having this book as our guide in our subject. So this is what our subject is: minimum mining data stream from frequent item set and clustering. This is chapter 4 and this is chapter 6 and 7. Okay, let's move ahead. So this is something an introduction of this book only, which help us to understand the unit 3 unit 4. Massive Finding of massive data sets by Geo Leskovic, Anand Rajaraman, and Jeffrey. The next video we will understand about unit 3 in brief,